Welcome back, ladies and gentlemen. We're now looking at 8.5, day 2, solving equations. Okay, our objective today is to solve quadratic equations by completing the square or using the quadratic formula, and then solve polynomial equations by factoring. Okay, first of all, if we're going to solve quadratics by completing the square, okay, basically what we need to do, for completing the square, we're going to take the first two parts of our quadratic and basically isolate them, move the 15 to the other side first, just to basically make room. So I'm going to have x squared minus 10x. Okay, the 15 is going to go to the other side. However, I am going to fill in a number right here. So as I add 15 to both sides, I'm going to have the 15 there. Okay, now my objective now is to put a number right here that makes the left side of this equation factor into some kind of a quantity square. And then we'll see what else happens after that. Okay, the few different ways of figuring this out, the shortcut that I like doing is simply take half of this number. The half of negative 10 is negative 5, and I actually write it on there on purpose. And then basically you just square the negative 5 to get a 25. Of course, this is an equation, so as I'm adding 25 over here to the left, and sometimes I put that plus and the blank sign just to remind myself to do this, I get a 25 over there as well. Alright, so now what happens over here? Well, easy enough, 15 plus 25, that's 40. Alright, and over here on the left side again, what I've done on purpose here is to create something that factors into x minus 5, or better yet, x minus 5 squared. Okay, now once I've reached this far, I have a pretty simple thing to do here. I can square root both sides of my equation. The square root and the square, of course, cancel each other out, leaving with an x minus 5. Okay, and one thing I'm going to beg of you is whenever you square root both sides, please remember that you need to take plus or minus of the other side. Okay, now the square root of 40, okay, well, hopefully in some manner, shape, or form, you can turn the square root of 40 into 2 root 10, because that's what I'm going to expect you to do. Okay, and basically from here, all we have to do is add 5 to both sides, and please do write this in the following order. Leave the plus or minus as the back half of the answer, and bring that 5 as the front half of the answer. So I've got 5 plus or minus 2 root 10. Okay, please do understand that this is two separate answers, one of which is 5 plus 2 root 10, and the other is 5 minus 2 root 10. So there is completing the square. Now, completing the square can be used on any quadratic equation. It's just a question of how messy the work is. Alright, so here we've got the 4x squared plus 13x equals 32. The good news is that 32 is already on the other side. The constant term's over there, so we're happy about that. The bad news is that 4 on the x squared. Now, the trick we discussed in the last problem only works when we have a coefficient of 1 on the x squared. So basically, to create a coefficient of 1, what I have to do first is divide everything through by whatever that coefficient is, in this case 4. Alright, so that leaves me the x squared, which I'm just ecstatic about. Woohoo! Alright, unfortunately, 13 over 4 doesn't reduce real well, so that leaves me with the 13/4 x. Okay, again, I am going to add something onto there, so I'll leave myself a space. And then the 32 over 4, well, this one happens to reduce to a nice clean 8, although it totally didn't have to. We just end up with nice numbers here. Alright, now again, the trick, basically, to create the quantity squared that we're looking for, we take half of 13/4. Well, if you think for a second, the way to get half of something, well, what's half of a half? Well, half of a half gets me to 1/4. Half of a third is a sixth. Okay, notice how the denominator simply doubles here. Alright, so basically any old fraction I have, I can simply take half of it by doubling the denominator. Now granted, it might reduce after you double the denominator, but whatever the case, you got something that's now half as much by simply doubling the denominator. Alright, so right now I know my left side will eventually factor into x plus 13/8 squared. Kind of messy, but hey, sometimes we have messy numbers in the world. Alright, but again, now I need to fill in my blanks. 13/8, when I square that, is 169 over 64. Of course, I now have to add that to both sides. 169 over 64. Alright, now I know you can all do this in your heads, but if we add this together, get a common denominator, all that fun stuff, we get 681 over 64. Okay, there's some good news and some bad news to that, but we'll get there in a second. Now, square rooting both sides again cancels out the square, which is good for us. So we have x plus 13/8 equals, okay, again I've got this plus or minus that I'm going to have to attach to things. Okay, now 681 is a number that doesn't have any perfect square factors. So basically what that means for us, he stays being a 681. Feel free to do a factor tree or something like that, but you don't have any pairs of factors, if that's the way you go about doing it. And then, of course, the square root of 64 is a nice clean 8, so notice I've made that 8 outside of the square root symbol. Okay, and here are the same basic steps in the last problem, just follow. I just have to get rid of the 13/8. So I subtracted from both sides, and now I've got negative 13/8 plus or minus the square root of 681 over 8. Now notice, since I have common denominators, what I can do is slam it together into one great big fraction, and I have something that should look very familiar to you. But there would be the answer to that relatively messy equation. Now from that last problem, you might have thought, hey, that looks a little bit like the answer I get when I use the quadratic formula. Well, you're 100% right. Okay, that messy work that we just did was so messy, somebody decided, hey, you know what, it'd be better if we had a formula to do that, and so we wouldn't have to worry about all those icky fractions and stuff. So, there it is. We've got the quadratic formula here. If I want to use that instead of completing the square on this thing, well, for the quadratic formula, first thing I want to do, just like factoring, is make sure I have a 0 on one side. And so since I don't right now, first thing I'm going to do is subtract the 2 from both sides, giving me a 6. And then I've got the 0. So again, the 0 I'm happy about. Okay, of course, now I have to identify my a, b, and c terms, which are 5, negative 12, and 6. And again, we just plug that into our good buddy, the quadratic formula, which you should have memorized right now. And if you don't have it memorized, make sure you get it tattooed into your brain very, very soon. Alright, so I've got x equals opposite of b. Okay, you might just write a positive 12 there, and more power to you if you do. Plus or minus the square root of b squared, so negative 12 squared, minus 4 times the a, which is a 5 in this case, times the c, which is a 6, and that's 11 all on top of a 2a. Okay, and then it's really just a big order of operations problem at this point. Alright, so got the 12 out of the left half of the numerator, got my plus or minus, big old square root. Okay, now depending how good you are, you may or may not be able to do this all in your head all at once, but here we go. Okay, the 5 times 6 is a 30, times 4 is 120, 12 squared is 144, 144 minus 120 pretty much is going to give us a 24. And that's all on top of a 10. Okay, root 24, okay, through some crazy means, hopefully you can get that to be 2 root 6 without too much hassle, and that's on top of a 10. And depending on the numbers, you might be done right here. However, in this case, notice that the all non-radical parts, the 2, the 12, and the 10, are all reducible by 2. So if that's the case, well, not specifically 2, but if it's reducible by any whole number, I would want you to do that reducing. So this reduces by 2, giving me a 6, plus or minus. Okay, please don't reduce the number under the radical, so it becomes root 6 still, and then it's all on top of a 5. And since that is not reducible any further, that would then be our final answer. Okay, again, remember that represents two separate answers, 6 plus root 6 over 5, and then 6 minus root 6 over 5. Alright, let's move on to factorable polynomial equations. Later on in the year, we're going to deal with polynomial equations that are not factorable, or at least easily factorable. Alright, so let's take a look at some that factor nicely for now. Alright, well, I've got x to the third minus 64 equals 0. Okay, now, rule of thumb, if I'm factoring, I want to have a 0 on one side, so I already have that here. Alright, now, hopefully you identify that as a difference of cubes. Alright, and so now just doing regular difference of cubes factoring, and if you're not familiar with that, you do need to brush up on it, because I promise it will show up from time to time throughout the year. But here we go. Okay, just ask yourself what things are being cubed right here. So basically x cubed, well, that's obviously x cubed, and then 64 is 4 being cubed. Okay, and again, if that's not something that comes to mind quickly for you, make sure you brush up on those things. Alright, well, for a sum or difference of cubes, you can do the factoring by simply taking the thing being cubed and then the thing being cubed in the front and back of a kind of a binomial. Whatever sign is there is going to be the same sign you're going to use initially. Okay, then you're going to open up a set of parentheses to do a trinomial. So what I just do is make it a little bit longer. Alright, and then the first term of our trinomial is the first guy here being squared. So in this case, x squared. Okay, then whatever sign I used here, I'm always going to use the opposite sign here. So in this case, a plus. Okay, for the middle term, you just take the product of the two things, ignoring any sign that you have. So x times 4 is just 4x. Okay, this last sign is always going to be positive. And for that guy, just like the front guy, we squared the front guy. For the back guy here, we're going to square the back guy. So that becomes a 16. Alrighty. So then I've got this second half, which looks like it might factor, but try as we might, we're not going to be able to get it to work. So basically I'm resorting to doing a linear sort of equation here as this factor, and I'm going to have to do a quadratic here. So basically I have x minus 4 equals 0, which is pretty easily solvable. I've got x equals 4. Okay, but over here I split off my quadratic factor, x squared plus 4x plus 16 equals 0. Alright, and again, since it's not factorable, I can either do the quadratic formula or completing the square, whichever you feel like. Just because I can do it in less amount of space, I'm going to do completing the square. So x squared plus 4x plus blank equals negative 16 plus blank. Half of 4 is a positive 2. Squaring that, I add a 4 to both sides. And I've got negative 16 plus 4, which is a negative 12. Okay, at this point, just like we did previously, I can square with both sides, but then something funny happens here. I've got x plus 2 equals, that negative sign is going to generate an I, since I'm trying to square root things. And just as a little side note, I suppose, the directions to this set of problems, and for this whole section really, are to find the real solutions. As soon as we find I, we're no longer dealing with reals. So for at least now, basically what that means for us is we just throw it out. And so what we have here is a single solution of x equals 4. Alright, let's take a look at one more of these polynomial equations. Again, I set it up with the 0 on one side. Of course, if you didn't have a 0 on one side, move things around until you have a 0. But here we go. Okay, I've got x to the 4th minus 11x squared plus 28 equals 0. Okay, now this looks a little bit like a trinomial, well, because it is a trinomial, but it looks like our normal reverse FOIL factoring, and it basically is. But just instead of having x squared here, that I could break up into x and x, this x to the 4th, I could break up into x squared and x squared. Alright, and then from there, because I'm looking for an x squared in the middle, if you think about the o and the I parts of FOIL, they're both going to be x squared terms, so I can generate this x squared term there. So it's just a question of breaking up a 28 to make an 11, and we can certainly do that by using a minus 4 and a minus 7. Okay. And depending on how you want to handle this, this x squared minus 4 is actually further factorable into x plus 2 and x minus 2 because it's a difference of squares. Okay, x squared minus 7, not factorable because 7 is not a square. Alright. And so from there, again, I've got a couple linear factors and then a quadratic factor. So the linear factors, of course, give me two little tiny equations that are very easily solvable. And the quadratic gives me something a little more complicated, although not over the top hard. Okay, so, well, I've got x equals negative 2, and then I've got a positive 2. And then the x squared minus 7, well, I'll add 7 to both sides here. Well, basically, I could use the quadratic formula or something, but that's really overkill. So doing that and then squaring both sides, I get x equals plus or minus. Don't forget the plus or minus. Okay, now the square root of 7, well, 7's prime, so I definitely can't do anything to simplify it, so I've just got plus or minus root 7. So now I've got that I can just add to my list of answers. Okay, now again, challenge yourself, tell me how many answers that is. Hopefully you just thought 4. Okay, of course if I wanted to right here, I could have wrote that as plus or minus 2. It's just whatever mood you're in. Feel free to write it either way. I will definitely accept it either way. But there you go. Alrighty, now there's the assignment. Not really much to do here other than leave it flashing on the screen for a second. Alright, of course, any questions? Ask me in class. I'll see you there.